Hi there, and welcome to this lesson. In this lesson, we're learning about the properties of triangles, okay? And on the properties of triangle, we're learning Pythagoras' theorem. And at this point, I'd remind you to set the video to play in 1080p HD. It's very important that you do so, and you can do so via the settings icon on the bottom right. And as the lesson progresses, if you have any issues at all, anything comes across unclear, please feel free to get in touch. Okay, we're here, we're always happy to help, and you can do so via the course dashboard. Okay, let's jump right into the lesson. So Pythagoras' theorem. What is Pythagoras' theorem? Pythagoras' theorem is a fundamental relation of the length of the three sides of a right angled triangle. Pretty much, you have the three lengths of the sides, the length of the sides of a right angle triangle, and you pretty much want to establish a relationship between all of them, i.e. if you have two of the sides, how do you find the other one? What's the relationship between the lengths of the three sides of a right angle triangle? And let's look at this right angle. Let's consider this right angle triangle here, and we have 90 degrees here, of course. And basically, the vertical part on the left there is called the opposite. Okay, so we call that the opposite. The horizontal base is called the adjacent, and this long part, this one that this inclined part, I'd say, is called the hypotenuse, and is usually the longer side of the right angle triangle. So from Pythagoras' theorem, there is a relationship between the opposite, the adjacent, and the hypotenuse, and the relationship is actually really simple. There really isn't much to it. It's that the square of the hypotenuse equals the sum of the squares of the opposite and the adjacent. Okay, for example, if my opposite was 2 and my adjacent was 3, and I asked to find the hypotenuse, I'd say I'd square 2, I'd square 3, and I add them together, and that will give me the square of the hypotenuse, and I'll just find the square root of my result, and it will give me my hypotenuse. So it's actually that easy. Now let's solve a few examples. Example 1. Example 1 says, using Pythagoras' theorem, solve for x in the triangle below. Okay, so we have a triangle here, and then in this triangle we have the opposite as 3, the adjacent as 4, and we've been asked to solve for x, which is the hypotenuse. Okay, let's go ahead and do that. And the first thing we want to do is we want to write down the relevant formula, which is the Pythagoras' formula. We have that h squared equals a squared plus o squared. Okay, and right after that, we just want to identify our parameters. What is h? H is x in this case. What is a? A is 4. What is o? O is 3. And then we can go ahead and impute our parameters into our formula. And what we have is we have h squared equals a squared plus o squared. We have x squared equals 4 squared plus 3 squared. And then we can go ahead and solve. So we have x squared, we square 4, we have 16. We square 3, we have 9. We have x squared equals 16 plus 9, 25. And then what we have is we find the square root of both sides. So we have the square root of x squared equals the square root of 25. Okay, and finally the square root of x squared is x, and the square root of 25 is 5. So you arrive at an answer x equals 5. Very simple. Okay, you basically just have one formula to work with. Okay, and once you input your values into the formula, it's just a matter of solving. So you squared 4, you square 3, you have 16 and 9, you add them together, you have 25. Okay, so you have x squared equals 25, and at this point you just find the square root of both sides, because if you find the square root of x squared, you get x. Then you find the square root of whatever you have on the right, i.e. in this case 25, and you have 5 as your answer. Okay, let's move on. Let's do another example. And example 2. Now example 2 says using Pythagoras' theorem, solve for y in the triangle below. And where do we have y? Y is our opposite. Okay, so in this case we've been given our hypotenuse and our adjacent and been asked to solve for the opposite, and it's pretty much the same thing. Okay, just a small difference, basically just a change of subject formula. And basically we have step 1, identify a relevant formula. We have that h squared equals a squared plus o squared. Okay, and the next thing we do, we identify our parameters. We have our h as 13, our a as 12, and our o is what we're looking for, y in this case. Okay, and what I'll do now is I'll just impute those values into my formula. So what I have is h squared 13 squared equals a squared 12 squared plus y squared. Okay, and then I'd make y my subject of formula, and then I'd have the y squared equals 13 squared minus 12 squared. Okay, this is pretty much just basic algebra, basic linear equations. And from this point on, just the same way we solved the last one, I have that y squared equals 169 minus 144, because the square of 13 is 169 and the square of 12 is 144. So I have the y squared equals 169 minus 144. And then what I have, 169 minus 144 is 25. So I have y squared equals 25. I find the square root of both sides and I end up with y as 5. It's that simple. Okay, so let's do another example, one final example. Example 3. And example 3 says using Pythagoras' theorem, solve for m in the triangle below. And in this case, m is our adjacent. Okay, so we've been given the hypotenuse is 17. We've been given the opposite as 8, and we've been asked to solve for the adjacent m. Let's go ahead and do just that. So first thing we do is we write down our formula. Okay, very important. And then after that, we identify our parameters. In this case, h is 17, a is m, okay, our adjacent is m, and our opposite is 8. Okay, and then all we have left to do is to substitute these values into our formula, and we have that 17 squared equals m squared plus 8 squared. Okay, and now we want to make m squared our subject of formula, and we have m squared equals 17 squared minus 8 squared, and then we have m squared. The square of 17 is 289, and the square of 8 is 64. Okay, so we have 289 minus 64, and what we have in the end is m squared equals 225. Okay, and to find m, we simply find the square root of both sides, and then finally we have that m in this case is 15. And that's it. There really isn't much to it. Pythagoras' theorem is a very simple principle. It's just one formula, h squared equals a squared plus o squared. That anytime you have a right angle triangle, the sum of the longest side, the hypotenuse, equals the sum of the other two sides. The sum of the square of the longest side, the hypotenuse, equals the sum of the square of the other squares of the other two sides, the adjacent and the opposite. Okay, that will be it for this lesson. That's the end of this lesson, and yeah, bye for now.